So sine and cosine found the same, correct? Your A is the same, your D is the same, your B is the same, but the C's are different. So for cos, if it was a positive cos, we look for the closest maximum and see how far it moved away from the y-axis. If it's a negative cos, we look for the closest minimum and see how far away it is from the x-axis, or the y-axis, not the x. That makes no sense. But with sine, put in your calculator y equals sine x. So go into your y1 and put y equals sine x. Into your y2, put in 0, and make the line thicker if you don't have a colored one. So look where they intersect. Is it on the y-axis? Is it beside the y-axis? Is it to the left of the y-axis? Where does the sinusoidal graph and the line y equals 0 intersect? On the x, but it's also on the y-axis, is it not? They intersect on the y-axis? Yeah, they intersect on the y-axis, don't they? So now go into y equals and go sine x plus 2 in brackets. Y equals sine x plus 2 in brackets. And in your y2, you have y equals 0. Where does it intersect on the way up? You need to put x plus 2 in brackets. Did you do that? Yeah. X plus 2 in brackets. So go, what mode are you in? Oh, this depends on what mode you're in. Okay, if you're in degree mode, go x plus 45. And if you're in radian mode, go x plus brackets pi divided by 4, because those are the same thing. So you're going to go into your calculator, y equals sine x plus 45, if it's in degrees. Or you can go y equals sine x plus pi divided by 4. So where is the intersection? Is it on the y now? No, that upwards motion, the one going upwards. Because remember your basic sine function, it intersected on the way going up, correct? Now it's actually 45 to the left, right? That intersection is 45 to the left because this is x plus 45. So now that intersection is 45 to the left. So what you need to do in order to find the sine, positive sign or negative sign, you have to draw the midline. So that's the very first thing you have to do. And the midline of this graph is drawn already, right? I drew it yesterday. It's right here. It's at y equals 1. So why did I make you guys do y equals 0 for that particular graph? Because what was the d value of this equation, of that sine equation? It was plus 0. So I was making you draw the graph and actually the midline. You just didn't know it, right? Now we're drawing the graph and the midline, but the midline's not at 0 anymore. It's at 1. Now the sine function, the real sine function that hasn't been moved at all, looked like this, right? And then you had a midline like this. So when it was a positive sine function, this is going upwards. It's where the intersection is on the way up. If it's a negative sine function, what would happen? You'd get the green graph now. Let's say, okay? So now it would still intersect with the y, but it's actually on the way down for your slope, okay? So the way to do this, to find how it's shifted, is if that intersection on the way up or on the way down is not on the y-axis, you have a horizontal translation for a sine. So the very first thing we want to do, if we want to find out where it horizontally moved for a sine graph, is we have to draw the midline. We've drawn that already, correct? Positive sine, we look for the closest upward slope, positive slope. The closest positive slope is this one. It could be this one, but you can't really see it, right? So this is the one where it's going upwards, and here's my intersection, correct? Do we agree? That should be on the y-axis. Is that on the y-axis? No, so our positive sine graph has moved. From the y-axis, how is it moved? Pi to the right. So we're going to go down here and go x minus pi. So you have to draw your midline, and you have to look at which one has a positive slope if you're looking for sine, where it intersects, right? Where they intersect is the important part. So if you don't draw the midline, you're never getting this. Okay? It's the very first thing you have to do. Then to do the negative slope, we're just going to look for the intersection, but we're going to look for the closest negative slope for the negative sine. So the closest negative slope is this one here, the intersection of this line and sine. How far away is it from the y-axis? It's on the y-axis. So has it been moved? No. So with cos and sine, or with coses, you look for the max and the mins. With sine, you look for where the midline intersects with the graph. Okay, where the midline intersects with the graph. So you have to draw the midline first, or you're never getting the horizontal shift. So now let's go backwards a few pages to those other graphs we were doing. So we're going to go back. So let's look at this one. What's the midline of 1? What was our d value when we figured it out? It was 0. Is the d always 0? No, we proved it on the previous one that it was 1, right? So we draw our midline. Our midline is 0. We know that. So we go to number 1 here, and I'm going to draw my midline. And then I'm going to look for my closest intersections. So this is my closest intersection up, and this is my closest intersection down. Do we agree? Mm-hmm. Are either of those on the y-axis? No. So both of our signs are actually shifted. Does that make sense? Okay. Do you see if I added this to cos yesterday, how confusing it would be? It gets really nasty. Okay. So which one is the positive sign? The one on the left or the one on the right? The one on the left, because it's the positive slope one. How far has it been moved over to the left? It's directly right in between 0 and pi. And the reason why I know that is it's half the distance between the max and the min, right? The max is at 0, the min is at negative pi, so it would be pi over 2. Pi over 2 left. So what would we actually put for positive sine? So do you see how the c value tells you if it's in radians or degrees? Negative sine, we'll go look for the one going downwards, for this one. And it's halfway between 0 and pi, so it's positive pi over 2 to the right, because so it's from the y-axis, so we're going to go minus pi over 2. Does that make sense? So you guys try this one. Try the number 3 one. Okay, this one has a midline at 0. This is the intersection positive. This is the intersection negative. Obviously, not going to be the most accurate deal. Now, because we actually have the min and the max, we can make it accurate because we can find half the distance. Now, there's been a question that's been given like this before that makes people a little bit, they're good if it's all on the right-hand side of the y-axis or all on the left-hand side of the y-axis to find the average, not when part of it's on one side and part of it's on the other. So remember, a lot of people will go 9 pi over 12 minus this. Would that get me the distance between the two? No. It's actually 3 pi over 12 to get you to 0 and 9 pi over 12 to get you to the max, right? So we'd have to do what to them to get the distance? Add them. So if we went 3 pi over 12 plus 9 pi over 12, what is it actually? 12 pi over 12, which is pi. So what's half the distance? pi over 2. Now people will say, okay, but then it's pi over 2. No, half the distance is pi over 2. So it's actually pi over 2 from here to here, and pi over 2 from here to here. So if I want to find out where this actually occurs, what am I going to have to do? Do 9 pi over 12 minus pi over 2, right? Because the distance from here to here is pi, right? The distance from here to here is pi over 2. The distance from here to here is pi over 2. If I want to find out where this dot is, how would I figure that out? I take the 9 pi over 12 and I'd subtract off the distance of this little piece here. What's the distance of this little piece? Pi over 2. So what's 9 pi over 12 minus pi over 2? It would be 9 pi over 12 minus 6 pi over 2, or pi over 12, sorry, which is 3 pi over 12, which is pi over 4. You could, if it's close enough. I can't, like, so these ones actually have ticks and you can see it. I can't see it. But on diploma, not on diploma questions that we have released to us, they've done ones where they give you the max and the min and it's not on a tick. So you actually have to find the distance between the two, divide it by 2 and subtract it off. This one is obviously on a tick, so you're okay. But they've done it where it's not. They'll give you the max and the min and they don't give you a tick in between. Okay? That's one of the ones that I find people challenge the hardest. You will be getting all those questions to try beforehand anyways. I have a booklet for you again that has all the practice diploma questions. I think there's 20 some odd questions on it again, like normal. If you remind me today, I'll release it today. So this one is pi over 4 to the right, and it's on the way up. So it's positive sign. So it's going to be minus pi over 4. And what's the other one? Sorry? 3 pi over 4 to the left. Okay? So literally that's all sine is to get the C. It's not hard. You just need to draw the midline, find the closest intersections. One going up is positive, one going down is negative. Make sense? Okay. Then we're going to go to the tan graph stuff. Tan's last. I'm going to do it first. So it's towards the end. It's actually 5.3, but I usually do it last, but I'm doing it today first because it's a Friday. Let's go to this one. So go ahead till you find this exact replica. Because normally I do it last, but like I said, it's a short lesson, so I just like to do it on a Friday. And then all we have left is word problems. Hurrah. Okay. Keep going. It's towards the end. It's example 1. It says y equals 3 tan x. Keep going. It's very, you do. I was like, Friday the 13th. Ooh, Friday the 13th. That's what it is. Yeah. This is the top of the page. This is the bottom. So go into your calculator and put in 3 tan 2x. Please, everyone, have your calculator in radian mode just so that we're all in the same mode. And then you can press zoom trig if you wanted to reset it so you can maybe see it. Tan graphs do not look anything like a sine and a cos graph, just an FYI. So did you zoom trig it? No. Yeah. Make sure you zoom trig it because it might be in the wrong. Yep, you're good. If it's drawn like a bajillion of them, or it looks like just a mess of lines, press zoom trig. Okay. So what you're seeing ultimately is you're seeing something that looks like this. It's not like exactly like this because it's been shifted, but it looks like this. Now, what's in between these things? Asymptotes. That's why it's curving. You actually have like an asymptote here, an asymptote here, and it's curving through them like rational did. Okay? Why is there asymptotes? Asymptotes are the lines that don't exist. So on a rational function, when you looked at a rational function, the denominator, whatever it couldn't be equal to, would actually cause you an asymptote on the graph. Yeah. Yeah, the TI-83s show solid lines instead, but that's still an asymptote. Yeah. The TI-83s believe that every graph is continuous. So it like just connects them all. It's just like, yep, you're continuous. I just like you to be continuous, and it does. So those straight up and down lines are actually breaks in the graph, but your calculator really wants that graph to be continuous. So it'll try and like connect the whole thing. So then it draws the asymptotes on the TI-83s. So why do asymptotes exist on tan graphs? Because tan graphs can be undefined. Remember when we look at the unit circle? Tan is 1 at the 45s, right? And -1 at the 45-degree angles. And tan is 0, because tan is y over x, right? So tan is 0 when y is 0 and x is 1 or -1. But tan is undefined when y is 1 or -1 and x is 0, right? When we have an x in the bottom. Where is x 0 on the unit circle? Where's x 0 on the unit circle? And 90 and 270, right? So on a basic tan graph, basic tan x graph, no shifts, no nothing, your asymptotes are going to be at 90 and 270, and every coterminal 90 and 270 from there on, backwards and forwards. You're going to have asymptotes. Okay? We could draw a tan graph just off your unit circle again, right? At the 45s, we'd go to 45 and 1, and then we could go to 135 and -1, because remember, that's where they occur. You could draw it off the unit circle as well, a basic tan graph. But tan graphs, unlike sine and cos graphs, have asymptotes because there's places where tan is undefined. Okay? Cotan would be the same, and so would secant and cosecant. Great thing is we don't have to draw them. We don't care about them really in the graph form in 30-1. We care about sine, cos, and a bit of tan. Okay? So when we look at the tan graph, the basic tan graph, let's not look at this one. Let's look at the basic tan graph. You can keep that one in, but because I'm just going to draw the basic tan graph. You guys told me that at 90, so we'll 90, 180, 270, 360, 90. You don't have to draw this. You can just pay attention. And then we have -90, negative, you don't have to, 180, -270, -360. Okay. So at 90, we'd have an asymptote. At -90, we'd actually have an asymptote as well, right? Because -90 is at 270. What's the distance from asymptote to asymptote? 180. The period of a sine and cos graph repeats itself every 360 or 2 pi, but a tan graph repeats itself every 180 or pi. That's important. Okay? So that you want to write down. Tan period equals pi over absolute value of b, or 180 degrees over the absolute value of b. They are different. So sine and cos graphs repeat themselves at 2 pi over b, but a basic sine graph is 2 pi because b is 1, right? And cos is 2 pi because b is 1. If I change my horizontal stretch, then my period changes. Same thing here. If I change my horizontal stretch here, what's my horizontal stretch on this graph? 1/2, but what's b? 2. It's 1/2, so the graph is going to narrow, which actually makes sense because the period would be pi over 2 now instead of pi. It halved, right? So it'd be pi over 2 or 90, depending on which form I wanted. Correct? The amplitude, what's the definition of the amplitude? The distance from the max to the min divided by 2. Absolutely. So but there's no max or min on tan graphs. They just keep going on forever, right? So what's the amplitude? Yeah, it doesn't exist. There is no amplitude. It goes on forever. So at 0, tan is actually, at 0 degrees, the height is 0, right? Because at 0 degrees, it would be 1 over 0. Or sorry, 0 over 1, because it's y over x, right? 0 over 1 is 0. And then at your 45, you'd get -1 down here. And you get +1. So at the 45, halfway, and then halfway, and then it would do this. And trig functions are, they keep going on forever. They're periodic, right? It keeps going, keeps going. So this graph, same thing's going to happen. I'm going to get myself another asymptote at 270 because it repeats itself every 180, and I'm going to get myself the same graph. And it's just going to keep doing that, doing that, and doing that, and doing that, right? So the amplitude's not going to change, okay? The domain of a sine and cosine graph were XER, right? They just kept going on forever. So if I wanted something smaller, I have to restrict your domain, correct? What's the domain of this graph? Is it XER? No, the moment there's an asymptote, it can't be XER because it doesn't exist everywhere. It doesn't exist at every single one of those asymptotes. Now, would you go, okay, x cannot equal 90, 180, 270, dot, 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 -90, -180, -270, dot, 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 dot? It would be nice to be able to do that. That is not the format they will let you do it in, but technically that is correct. It can't equal all those things. But just like when we did x-intercepts of sine and cosine graphs, we have to do a general solution. And just like that, we have to do a general solution for our domain. So what's the first one it can equal to? What's the first positive? Oh, not this one, sorry. This one. It would be, the domain would be x such that x cannot equal 90. Remember general solution, what do we do after that? We put the period. When it repeats itself. When does this one repeat itself? That top one. I'm just doing the basic tan one. This one is just y equals tan x. We will deal with the one that is not the basic one after that. How often do these repeat themselves? Every 180. This one repeated itself every 90 because it's shifted. But how often do the asymptotes exist? Right? Every 180. Because it was at -90 to 90 or 90 to like 90 to 270. It's 180, right? Every 180, this baby's going to repeat itself. So we're going to have 90 plus what? Go away. Okay, 90 plus 180, what? NEI. Or we could have x such that x cannot equal pi over 2 plus pi n NEI. So it equals everything else, right? Just not those. So if it asked you where your asymptotes were, what would change? If it asked you where were the asymptotes, what would change between that and where are the asymptotes? It would be equal to. The asymptotes would equal that. The domain does not equal that. The asymptotes do equal that. Okay? What's the range on this baby? Infinite. Keeps going on forever and ever, up and down, right? There's no amplitude, so what would the range be? YER. Or if you want an interval, it would be negative infinity, positive infinity. So that's a basic tan, right? Now, if we move to this tan here, what's the domain? Well, this one, the period is shorter, right? It's not at 180 now, it's at 90 between each, right? Okay, look at your calculator. You have it in your calculator, right? Where does the asymptote break through? And if you don't know where the asymptote breaks through, make sure you change your x scale to something that you can see where it actually crosses through, right? So make your x scale maybe be 45s. 45s are really nice for tans often because they're like 90s and 45s and 180s and etc. Okay, I would make my x scale be a 45 or a pi over 4 if you're in radians, right? Because you can't put 45 in if you're in radians. That's not going to work. It's going to be really wonky. You won't even see a tick. I'm just going to make your x min the pi. Just because you can't see enough to make a good judgment. Oh, the person's trying to find their phone. Oh, no, they're not. Someone else's phone is ringing. Okay, so where are the asymptotes hitting now? At 45s, right? Now, why would that be? Well, did the graph shift to the right or the left at all? No, this graph is still symmetrical about the y-axis, correct? So instead of the asymptotes being at 90, negative 90 and 90, which would be a distance of 180, our distance now has to be 90 between each other, correct? So now it's going to be at negative 45 and 45. If we have a horizontal translation, that throws the whole thing right out of whack. But if it doesn't, it's going to be symmetrical about that y-axis. Okay, so we know that this is at 45 or pi over 4. And this is at negative 45 or negative pi over 4. Okay, so my first positive one is going to be x can't equal pi over 4. Plus, now is it 180 or is it pi n? Because it's always 180? No, the period equation is always pi divided by b, right? So what's actually the period of this graph? Well, it's pi divided by 2. We did a period. This thing actually repeats itself every 90 because the horizontal stretch, right, changed it. So it's actually going to be pi over 2n NEI. Does that make sense? So when you're doing the period of a sine or cos graph from an equation, you always do 2 pi divided by the absolute value of b. But if you're trying to find the period of a tan graph from an equation, you're going to do pi divided by b because it's only half of it. It repeats itself every 180. Okay? Unless the b changes it. And then the range is easy. You should be able to state the transformations of a tan graph, but why wouldn't you be able to? It's the same as every single time, right? A gives you vertical stretch, gives you reflection in the x-axis. B gives you horizontal stretch, reflection in the y-axis. Horizontal translation, vertical translation. Doesn't matter that it has a tan in it. Yeah. So the 3 would actually make it, it's still going to stretch it by 3. So it'll actually, that's how it makes it narrower because it stretches it faster. So this graph now actually repeats the same amount of stuff in 90 instead of 180. So this one, it would have went like this in the 180, but now in the 90, it's going to vertically pull that, and so now it's going to be a steeper graph. No, it'll still affect the y's, but it just makes it look like it's affecting the x because the y's, it'll be, instead of being at say 1 or at 45 and 1, it's now going to be at 45 and 3. So it makes it steeper faster. Instead of being at negative 45 and negative 1, it's going to be at negative 45 and negative 3. So it just pulls that graph faster. And that's how it makes it, that's how why the period can be shorter, because the graph is narrow. Like, that's how they can force it to be that way. It just makes it a narrower graph. the period makes it shorter, the amplitude makes it wider, or go up faster kind of thing. So it looks like it's affecting the x's, but it's not actually. It's affecting the y's. Does that make sense? So A in this case is not the amplitude. So many people tell me the amplitude's 3 because they're so used to saying the amplitude's the absolute value of A. But remember, tan graphs don't have an amplitude. They just keep going. Okay? And then I'll give you your homework.